Today we're going to talk about isosceles and equilateral triangles. Our vocabulary for today is legs of an isosceles triangle, vertex angle, base, and base angles. Recall that an isosceles triangle has at least two congruent sides. Notice that it says at least two congruent sides. So all equilateral triangles are also isosceles, but an isosceles triangle is not necessarily equilateral. The congruent sides are called the legs. The vertex angle is the angle formed by the legs. The side opposite the vertex angle is called the base, and the base angles are the two angles that have the base as a side. So in our picture here, we have the top line and the bottom line congruent to each other. Therefore, 1 and 2 are base angles, and 3 is the vertex angle. Notice that angle 2 is opposite the bottom side, and angle 1 is opposite the top side. Next we have the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite the sides are congruent. So in our picture on the right, we have AB and AC congruent to each other, so angle B is congruent to angle C. Those are your base angles. The converse of the isosceles triangle theorem is also true. If the two base angles are congruent, then the two sides are congruent. So if angle E and angle F are congruent, then segment DE and segment DF are also congruent. The isosceles triangle theorem is sometimes stated, base angles of an isosceles triangle are congruent. So here we have an example where we want to find the measure of an angle. So we have that measure of angle F is equal to measure of angle D based off of the isosceles triangle theorem because they are the base angles of an isosceles triangle. So the measure of F plus the measure of D plus the measure of A is equal to 180 by the triangle sum theorem. Substituting all of our values in, we have x plus 22 equals 180. Combining everything, we put x plus x together, which is 2x, and subtract 22 from both sides, which gives us 158. Dividing both sides by 2, we get that x is equal to 79 degrees. And measure of angle F was x, so measure of angle F is equal to 79 degrees. For this one, we have measure of angle J equal to measure of angle G. Notice that the base angles are on the side now because GH and JH are the two congruent sides. So J is equal to G. Here we have, for measure of angle J, 3x, and for G, x plus 44. They put them backwards, but that's okay. You can put them in either order because they are just equal to each other. Now we want to subtract x for both sides, which gives us 44 equals 2x, and divide by 2 to get x equals 22. Now here you need to be a little more careful because angle G is not equal to x. It's equal to x plus 44. 22 plus 44 is equal to 66, which is the measure of angle G. The following corollary and its converse show the connection between equilateral triangles and equiangular triangles. If a triangle is equilateral, then it is equiangular. It's also true that if a triangle is equiangular, then it is equilateral. So here we have a triangle where all of the sides are marked as congruent, so it's an equilateral triangle. Since it's equilateral, it's also equiangular, so all of the angles are equal, and they're all equal to 60 degrees. So if L is equal to 60 degrees, then 2x plus 32 is equal to 60 degrees. Subtract 32 from both sides, and divide by 2 to get x equal to 40. For this one, we have all of the angles marked, so it is equiangular, therefore all of the sides are equivalent. So I made sure to put tick marks on each of the sides to show that they're congruent, and then set them equal to each other. So we have 5y minus 6 equals 4y plus 12. If we subtract 4y from both sides and add 6 to both sides, we get y equals 18.
Here are the rules for constructing an equilateral triangle. First, you measure the length of the initial side. Put up the point of your compass at point B and draw an arc. Move the point to point A and draw another arc. The third vertex of the triangle is where the two arcs cross, so go ahead and connect from A to C and from B to C, and you'll have an equilateral triangle. For this example, we're going to go ahead and construct an equilateral triangle using a compass and a straight edge. So the first thing we want to do is measure from B to A using our compass. So we take our compass, put the point at B, and measure how far out A is. So we go ahead and measure that, and then we put a nice arc with our point at A. We're going to make a nice arc from B and up. And then we do the same thing starting at B and go up this way. Notice that either way you're starting with the same distance. This is the distance from A to B, and that's how big our arc should be. Now where those cross, that's where we put point C. So we can go ahead and put point C here where those two lines cross, those two arcs. Now you take your straight edge. I'm just using the edge of my protractor here. We can take our straight edge and connect, and take our straight edge here on this side and connect. And that gives you a beautiful equilateral triangle.
Here's your lesson quiz. Go ahead and take some time to practice these and see if you have any questions. If you have any questions, ask them during class tomorrow. Otherwise, we'll continue and practice with more of this later on.